students, we're going to go over Hess's law in this video. So when we initially brought up the subject of enthalpy, or the heat content of the system, we were looking at our reaction. We were looking at our values in our packets to look up the heat of formations of each reactant in each product, factoring in the coefficients there, adding our products, adding our reactants, and subtracting our products minus our reactants to find the change in enthalpy. When we do that, when we were calculating that delta H, we weren't looking at the path that the reaction took or how many steps the reaction has to go through in order to reach our products. We were only looking at our initial reactants and our ending products. But the thing is, reactions don't always occur just in one step. They might form intermediate products, temporary resting points until we can find or form our actual products. So when you look at this, graphic down here on this slide, it shows the synthesis of sulfur trioxide, which we would assume would take sulfur and some oxygen gas and put them together to make sulfur trioxide. But it really occurs in a couple of different steps, where the sulfur and the oxygen first react to form sulfur dioxide, and then the sulfur dioxide reacts with oxygen again to form that sulfur trioxide. So what Hess's law does is it says that we can take the enthalpy change from each of those steps and add those enthalpy changes together to get the overall enthalpy change of the reaction itself. So when we calculate Hess's law, we're going to be looking at the different steps that a reaction takes, the enthalpy associated with each of those steps, and we're going to figure out how to get those enthalpy changes factored in together to give us our overall reaction itself. It's going to require us to flip our reaction or multiply our reactions in order to get achieve that overall reaction that we're trying to get to. So let's see how that's going to look. Okay, so in this example here, how much energy, and these are supposed to be arrows, sorry about that. How much energy is involved in the decomposition of hydrogen peroxide? So this here, this is our final reaction. And actually, I'm going to go ahead and highlight that instead. This is our overall reaction. That's what we're trying to achieve when we look at our intermediate steps. And A and B here, as they're listed below, those are the different steps that these reactions are going to go through in order to get that final product. So when you're looking at the steps, they're not necessarily written in a way that makes sense to the final overall reaction. So when you're looking at this, first off, it's a decomposition of hydrogen peroxide. So hydrogen peroxide has to be a reactant in our overall reaction. Well, when you look at step B has the hydrogen peroxide as a product. So we had to flip that reaction in order to get the hydrogen peroxide on the reactant side. So we're going to flip that reaction. We're going to make it H2. O2 decomposes to make H2 plus O2. Now, when we flip that reaction, that means we have to change the sign of our delta H. Because as we know, when we calculate our delta H, it's products minus reactants. So flipping it would change that sign. Now, our overall goal is to get our two steps, our A step and our B step, when we add them together to get this final highlighted overall reaction step there. That means the same quantities, so the same coefficients of things, and nothing extra, okay? So we want to make sure that we get rid of any of those hydrogens, because hydrogen does not show up in our overall reaction, and we want to get two hydrogen peroxides. So we're going to have to double step B in order to get two hydrogen peroxides to end up with. So we want to multiply step B by 2. It means we multiply all of these by 2, and we're going to have to multiply our delta H by 2. Okay, so that would be 376 here. So now we have two hydrogen peroxides decomposed to form two hydrogen gases and two oxygen gases. Now you can see when we look at steps A and B, because we have two hydrogen gases on the reactant side in A and two hydrogen gases on the reactant side of B, we can go ahead and cancel out those two hydrogen gases because they appear on both sides of the reaction and therefore they're not actually there. You'll see that we have one, so let me cross this out so we don't get confused. We already flipped that reaction. We have one oxygen gas on the reactant side up in step A. We have two oxygen gases on the product side on step B. So that means that this is now gone and this has just gotten down to 1. So now we actually have our overall reaction. We've got 2 hydrogen peroxides here. We've got the 2 waters on the product side here, and we have the 1 oxygen on this side here. So once you get your different steps to add up to your overall reaction, you have completed, finalizing and trying to get those, everything on the right side. Your enthalpies are now correct to the point where you can add those enthalpies together. So we would add that 376, and remember it's positive because we flipped step B, and we'll add that to the negative 572. So our delta H for the decomposition of hydrogen peroxide is going to be negative 196 kilojoules of energy. All right, so let's take a look at example 2 here. I'm going to go ahead and highlight our overall reaction so that stands out. This is what we're trying to get to. All right, so when we look at our different steps, we've got 3 steps to look at this time. We want to get those 3 steps to equal this highlighted overall reaction here. So look at each of those steps to figure out what we need to do and which ones we need to manipulate, okay? So first off, I see that CS2 has to be on the reactant side because that's where it is on our overall reaction. So that means step C is going to have to get flipped so that CS2 ends up on the reactant side. So I'm going to go ahead and flip this step. Let me cross out this so we don't get confused. That means I have to change my sign, so that is now negative, okay? Now, I see that O2 has to be a reactant, okay? O2 is a reactant on steps A and B, so that's good. CO2 has to be on the product side, and it's on the product side in step A, so that's good. SO2 is a product, and it's on the product side on step B, but SO2, I have to have 2 of them to get my overall reaction. I only have 1 in step B, so that means I have to double step B. So I have 2 of everything now in step B, and I have to multiply that part by 2. So that would be negative 593.6, okay? So now I've got 1 CS2 down here on the reactant side. I need to have 3 oxygens, which I have when I add those 2 together on the reactant side. I need to have 1 CO2 on the product side, which I have, and I need 2 SO2s on the product side, which I have there. So now I can add up my enthalpies, so negative 393.5 plus my negative 593.6 plus my negative 87.9 because I flipped step C. So that means my delta H for this reaction is going to be negative 1075 kilojoules of energy. All right, so let's take a look at this one in your packet. This is number 1 on page 12. It's titled Hess's Law Practice Problems. Now, I'm not going to go over this step by step with you. I'm going to ask you a series of questions so that you can answer during your ed puzzle. So first off, I want you to look at this. You've got your overall reaction here. Let me go ahead and highlight it. That's your overall reaction. That's what we're trying to get to. So my first question, are we going to have to flip any of these steps? Are we going to have to flip step A, or are we going to have to flip step B? So look at that. Look over the ones in your packet. It might be easier to look at than the one up here on the screen. And see if you have to flip anything. Don't forget to change the sign if you flip something. Then I want you to look at, are you going to have to multiply any of these reactions or any of these steps? In order to get your overall reaction, are you going to have to multiply any of those steps, step A or step B? If so, which one are you going to multiply and by how much to get those coefficients that you have in your overall reaction? Don't forget to multiply that delta H for that particular step as well. And then once you've manipulated both of your equations the way you need to, add your delta H's together. And what's that final delta H for your overall reaction? Then let's take a look at problem 2 here on page 12, the Hess's Law practice problems. Here is your overall reaction. That's what we're trying to get to. All right. Do you have to flip any of the reactions? Any step A or step B? Does anything need to be flipped in order to achieve that overall reaction there? Do we have to multiply any of our steps, step A or step B, in order to get our overall reaction? And then what's our delta H? Once you've added everything together, what's our delta H value? How are we going to solve for that? Okay, so if we have any questions while we're trying to solve these Hess's Law problems, feel free to reach out so I can help you guys out. Okay, thanks.